Hi students, welcome to a new video. This video is a continuation of the last video of light. So in the last videos we have seen reflection of light, spherical mirrors, plane mirror, image formation of plane mirrors, and we have done some problems. So those who have not seen the last videos, the link is given in the description. So please watch it. Today's session is very important because in this session we are going to discuss the Cartesian coordinates, which is sign conventions of spherical mirrors, which is very useful for doing the problems. And in this video I'll give you some tips for remembering these sign conventions, which is very useful. So please keep watching. So today we are going to discuss the following topics: sign convention of spherical mirrors, mirror formula, and magnification. So using this sign convention we are going to do the problem. So this session is very important. You will get at least one question from this session. So we will move on to the topics. So we can go to the sign convention of spherical mirrors. So this is a spherical mirror. So this is the principal axis. This is the pole of the mirror. So we are keeping, the first rule is we have to keep the object on only in the left side of the mirror. We have to keep the objects on the, this is the object. We have to keep the object on left side. Object and left side of the mirror. So the incident light is coming from the left side of the mirror. So the incident light is coming from the left side of the mirror. So next point is we have to take the pole as the origin. Pole as origin. We have to take the pole as origin. That means all the measurements are taken with respect to the pole of the mirror. That is the second rule. Pole is taken as the origin. And third rule, this is the right hand side of the mirror and this is the left hand side of the mirror. So if you are taking the measurements to the right side of the mirror, it is taken as positive. That is, with respect to the pole, if you are taking measurement to the right side, it is taken as positive. Right side taken as positive. And if you are taking measurement to the left side, it is taken as negative. That means opposite to this direction, it is taken as negative. It is taken as negative. So next rule is the measurements which is taken in the upward direction to the principal axis, it is taken as positive. Upward direction, it is taken as positive. And the measurements taken in the downward direction to the principal axis, it is taken as negative. Downward directions, it is taken as negative. So these are the rules for the sign case of spherical mirrors. First one, the object should be always placed in the left hand side of the mirror and the incident light is always coming from the left hand side of the mirror. And for all the measurements, the pole is taken as the origin and the measurements taken right side of the pole is taken as positive and to the left side it is taken as negative, and the measurements which is taken in the upward direction to the principal axis is taken as positive and the downward direction it is taken as negative. Next we have to see some terms related to the spherical mirrors. These terms have to be familiar for doing the problems. So first term is U. U means the object distance. U means the object distance, that is the distance from the pole to the object. And next is V, that is image distance. Image distance, that is the distance from pole to the image formed. And next is F. You are familiar with the term. F means focal length. F means focal length. Next is H. H means height of the object. Height of object. Next is H dash. H dash means height of image. height of image. So these are the terms: U object distance, V image distance, F focal length, H height of the object, H dash height of the image. Next we have to see the different signs for U, V, F, H and H dash in case of concave mirror and convex mirror. Concave mirror and convex mirror. This is the concave mirror and this is the convex mirror. This is the principal axis, this is the pole, this is the pole of the mirror. So next we have to see whether the object distance means U. The object distance is positive or negative. So first is U. So U means the object distance. Here we are keeping the object on the left side of the mirror. Here also we are keeping the object on the left side of the mirror. So all the measurements to the left side of the mirror is taken as negative. So in this case also the value of U is negative because we are taking the measurement to the left side of the pole. So the measurement taken left side is always taken as negative. So in all the cases, in case of concave mirror or convex mirror, the value of U is negative. So next is V. V. In case of concave mirror, we have seen the image formed is only one case we are getting a virtual image. Only one case we are getting a virtual image behind the mirror. So in that case only the value of V is positive because we are taking the measurement to the right side of the mirror. So in that only one case, in case of concave mirror, the value of V is positive. The mirror image formed is on the behind the mirror or the right side of the mirror, it is taken as positive. In all other cases, the image is formed real and inverted. So we are taking the measurement to the left side, left of the pole. So here the value of V is negative. So in all other cases, the value of V is negative. Only one case is there, we are getting an image behind the mirror, it is virtual and erect. So in this case only we are measuring from to the right hand side of the mirror. So in that case of concave mirror we are getting the value of V as positive. In all other cases we are getting a real and inverted image. So in front of the mirror we are getting, in the left hand side of the mirror we are getting a real and inverted images. So we are getting, in all other cases, the value of V is negative. This in case of convex mirror. In case of convex mirror, we know that in all the cases we are getting an image behind the mirror or on the right hand side of the mirror. So in all the cases of convex mirror, the value of V is positive. The value of V is positive for all cases of convex mirror. Next, F is focal length. Focal length. In case of concave mirror, we know that in all the cases the focal length is in front of the concave mirror. We have seen the focal length in case of concave mirror and convex mirror. So in that case we know that principal focus is in front of the concave mirror. So focal length is always, this is the focal length, this is the focal length. So we know that we are taking measurement to the left hand side of the pole. So the value of the F is negative in case of concave mirror. So in convex mirror, so here we know that we get a principal focus behind the mirror or right hand side of the mirror. So this distance is the principal focus. So we are taking a measurement to the right hand side of the pole of the mirror. So the value of F is positive because we are taking measurement to right hand side of the pole. So in that case the value of F is positive. So next is H. Next is H. H means the height of the object. In all the cases, the height of the object, it is upward direction, upward to the principal axis. So in all the cases, in this case of concave mirror, H is positive because in the upward direction to the principal axis. In case of convex mirror also we get height of the object as positive in all, because here also we are keeping the object in the upward direction. So in this case also the value of H is positive. Next is height of the image. We know that in the case of virtual image only we are getting an image in the upward direction in case of concave mirror. So in that case of only we are getting H dash as positive for virtual image. So In case of real image, we are getting we are getting an image in the downward direction. So it is the downward direction to the principal axis. So we are taken as negative. So for real images, h dash is negative, and for virtual images, h dash is positive. So what in case of convex mirror? In all the cases of convex mirror, we are getting a virtual image. So in this case, it is always positive. So these are the signs for this U, V, F and H dash in case of concave mirror and convex mirror. So these signs are very important for doing the problems. To memorize this easily, I will just draw a figure. So we can do two quadrants. So this is the positive quadrant and this is the negative quadrant. So this is the upward direction and this is the rightward direction. So the measurements in the upward direction and the rightward direction we are taking as positive. And here the measurements taken to the left hand side and downward direction, it is taken as negative. So this is for your easy remembering. It is in the upward direction and right hand side it is taken as positive, and the left hand side and the downward direction it is taken as negative. So you can easily remember this. By looking this figure, you can easily remember these sign conventions. Next we have to discuss is mirror formula. Mirror formula means the relation between U, V and F. The relation between image distance, object distance and focal length. So this formula is very important for doing the problem. So you have to remember this formula. So next we have to discuss is mirror formula. So the relation is 1 by U plus 1 by V is equal to 1 by F. So 1 by, this is the relation between the object distance, image distance and focal length. 1 by U plus 1 by V is equal to 1 by F. What is U? Object distance. Object distance. V, image distance. And F, focal length. So you have to remember this formula for doing the problems. 1 by U plus 1 by V is equal to 1 by F. So next we have to see the magnification. Next is magnification. Sometimes the size of the image will be small as that of the object. Sometimes it will be equal to the size of the object, or sometimes it will be greater than the size of the object. Three cases are there. So magnification means the size of the image with respect to the object. The size of the image with respect to the size of the image with respect to the size of the image with respect to the object. How much? The size of the image with respect to the object is known as the magnification. How much it is magnified. That is, the size of the image with respect to the object is known as magnification. So the equation to find the magnification of the object, magnification. So magnification denoted by the small letter m. So magnification denoted by height of the image divided by height of the image by height of the object. Height of the image by height of object. So we can write m is equal to h dash, height of the image divided by height of the object. This is the equation to find the magnification. A magnification is equal to h dash divided by h dash by h, height of the image divided by height of the object. Next we have to see the sign for this h dash and h for virtual and real images. So h dash for virtual image. Virtual image. For virtual image. Virtual image height is always in the upward direction. For convex mirror, In case of concave, this is the h dash. For convex mirror, this is the h dash. So what? It is on the upward direction to the principal axis. So virtual image h dash is positive. And for real image, for real image we know that for real image it is always in the real and inverted. It is in the downward direction to the principal axis. For real image h dash is negative. For real image the h dash is negative. So for concave mirror, there are two cases for h dash. For concave mirror, two cases are there. One is virtual image is formed in one case. So in that case only h dash is positive virtual image. For concave mirror, two cases are there. And for the real and inverted images, it is negative. For real and inverted image in case of concave mirror. And next in case of convex mirror, for convex mirror we know that in all the two cases are there. In all the two cases the image is formed in the upward direction to the principal axis. So in all the cases convex mirror h dash is always positive. In all the cases of convex mirror h dash is positive. Concave mirror, two cases are there, virtual image and real and inverted images. So virtual image only we are getting h dash. In that case only we are getting h dash as positive. In all the other cases we are getting h dash as negative. Next we have to see the sign convention for magnification. We know that m is equal to h dash divided by f. So for virtual image, for virtual image we know that h dash is positive, h dash positive and h is also positive. So magnification positive for virtual image. For real image h dash is negative, h is positive. So magnification is negative. So for virtual image magnification is positive and for real image magnification is negative. So for concave mirror, two cases are there. Magnification positive for virtual image and magnification negative for real image. And in case of convex mirror, magnification is always positive because in all the cases of convex mirror we are getting virtual images. So in all cases of convex mirror the magnification is positive. So next case we have to see. First case, if m is greater than 1. If m is greater than 1, what is the meaning of this one? If m is greater than 1, the image means that the image is greater than the size of the image is greater than the size of the object. If magnification is greater than 1 means the size of the image is greater than the size of the object. If m is equal to 1, that means the size of the image is equal to size of the object. If m is equal to 1, the size of image is equal to size of object. And third case, m is less than 1 means size of image is less than size of object. So these are three cases. If m greater than 1, size of the image is greater than the size of the object. If m is equal to 1, the size of the image is equal to size of the object. And if m is less than 1, the size of image is less than the size of the object. So first case we have seen in case of concave mirror. In case of concave mirror. In case of concave mirror, all the three cases will come. In some cases we can see size of the image is greater than size of object. In one case, when we are keeping the object as center of curvature, the size of the image is equal to size of the object. In other cases, we can see size of the image is less than the size of the object. So in concave mirror, sometimes it will be m is greater than 1. In one case, m is equal to 1, and other case, m is less than 1. In convex mirror, in case of convex mirror, in all the two cases, in case of convex mirror, in all the two cases we are getting diminished images. Diminished means the smaller than the size of the object. So in case of convex mirror, the size of the image is always less than 1. Thus in case of convex mirror, the magnification is always less than 1. So next case is, third case is plane mirror. In case of plane mirror, m is always is equal to 1. What's the reason behind that? In case of plane mirror, we know that the size of the image is always equal to the size of the object. That means the magnification of the plane mirror always is equal to 1. So these are the three cases: concave mirror, m greater than 1, m equal to 1, or m less than 1. In case of convex mirror, the image formed is always less than the size of the object, so magnification is less than 1. In case of plane mirror, the size of the image is always equal to size of the object, so here the magnification is always equal to 1. Next is, there is a relation between magnification with the image and object size. That is, there is a relation between magnification u and v. The relation is m is equal to minus of v by u. What is v? Image distance divided by image distance by object distance. Image distance by object distance. So there is a relation m is equal to minus of v by u. So next, first we have studied the relation m is equal to h dash divided by h. So we can give us equation 1 and this as equation 2. When we are comparing these two equations, we can say the LHS are equal. So we can write h dash by h is equal to minus of v by u. So this relation is also important for doing the problem. H dash means height of the image, h height of the object, u v image distance, u object distance. So this relation is also useful for doing the problems. Thanks for watching this video. In the next section, we will discuss the problems related to this portion, sign conventions, which is important for the exams. We will meet in the next video.